Hello and welcome. My name is Viren Mathuria. I'm the software marketing manager at Atlas Copco. And today we're talking about methods of plant floor error proofing using software. In this seminar here, we'll learn about the benefits associated with software for plant floor error proofing itself. So let's jump right in. We'll start by defining what is error proofing and how Industry 4.0 is driving specifically the need for plant floor error proofing. Then we'll talk about different types of manufacturing software and their effectiveness in plant floor error proofing. So to start from the start, the first question to ask is, what is error proofing? We all in the world of manufacturing know it's a way to avoid mistakes, because who likes making mistakes, right? If we look at the history of error proofing, Shigeo Shingo, a Toyota engineer from the 1960s, came up with this concept of poka-yoke. The internal term initially used was baka-yoke, which sadly meant foolproofing. Of course, that didn't catch on for long because it offended people inside and outside of Toyota. There's a widespread myth about error proofing or poka-yoke. It's that it only can be accomplished by hardware devices such as limit switches, guide pins, etc. And it can only be implemented by engineering departments. Well, the truth, on the contrary, is poka-yoke is a philosophy. So it can be anything that helps avoid a mistake. A physical device, a procedure, a software, or even a human inspector, they all pass as poka-yoke. If you look at manufacturing publications today, as market leaders, I'm sure you subscribe to at least some of these, and any publication that you look at, you can't escape without reading the word Industry 4.0, Smart Connected Assembly, IoT, etc. We're in the middle of this significant transformation regarding the way we produce products, and all in part but thanks to digitization of manufacturing. This transition is so compelling that it's being called as Industry 4 to represent the fourth industrial revolution that is occurring in manufacturing today. Advances in technology such as big data, cloud computing, machine learning, etc. are forming the basis of this fourth industrial revolution. Smarter factories are producing products with greater efficiency than ever before. They are reacting to changes in consumer demand at lightning speeds. And they're focusing on human factors more than they ever did to make sure that users and user experience are at the core of this revolution. Now that we've talked about error proofing, let's start with plant floor error proofing. Let's say you had to fasten 3 bolts, 5, 10, and 15 Newton meters using a 10 Newton meter tool. What would be the result? We know one would be really awesome, the second one might be just okay, and the last one blatantly loose. Had you known the spec of these bolts, wouldn't you use the right tool to begin with? Same concept goes for error proofing, right? To effectively error proof, we must know the types of errors we are trying to prevent. Research shows that most of the errors in the plant floor are human, followed by method and then materials in the end. A recent 2017 survey sponsored by GE Digital directly attributed about 23% of unplanned downtime to human error alone. And we know with Industry 4.0, increasing product variation that's stemming from consumer demand will push this human error percentage even higher. That's one of the reasons why Industry 4.0 considers human factor as one of the key pillars of the factory of the future. And it's true, contrary to the common notion that machines will replace humans, humans will actually play key decisive roles on the plant floor. The next question is, why error proofing? And the simple answer is cost savings, right? Bottom line. We all know small mistakes can lead to huge disasters. If you ask the scientists and engineers of the Mars orbiter, a $327 million spacecraft that was destroyed because of an error in converting between units of measurement, they'll tell you that. We error-proof in the world of manufacturing for quality and efficiency. But besides these commonly known reasons, of error-proofing, factories of the future will error-proof to remain relevant and to remain agile. If we look at the total number of recalls here in the US in just the first 3 months of 2019, we can obviously conclude, anybody can, that there's a tremendous, solid, and huge demand for error-proofing. The not so obvious conclusion that you can derive if you put your Industry 4.0 lens on is that the traditional lean manufacturing and SPC models alone, they're not as effective anymore in today's high variability processes, the processes that are driven by consumer demand of highly customized goods. Now, if you take a look at the full picture of the evolution of manufacturing technology, you can clearly see that starting in early 2000s, the lines between hardware and software started to blur. Software solutions are quicker than hardware to deploy, to configure, customize, and upgrade, and they allow for more intelligence, which drives the greatly required software-first mentality on the plant floor. Now, manufacturers from all segments are asking themselves first if a solution can be derived from software rather than hardware. In simple words, in our context of this discussion here, they're asking if software can be used for plant floor error proofing rather than the traditional sensors and actuator-based hardware error proofing. In terms of agility, Industry 4.0 defines that factories of the future should be able to react to changes at lightning speeds, to cope with shrinking product cycles, transient customer loyalty, and the frequent technical breakthroughs that, in all honesty, happen pretty much every day now. Like many other studies, a recent study from PricewaterhouseCoopers summarizes that flexibility on the plant floor without actually changing the program code will be indispensable for the factories of the future. Software that can be configured by users to adapt to frequently changing customer needs. Now that we know why error-proofing using software, let's take a look at the various manufacturing software offerings. Before we move forward in understanding different types of manufacturing software, I think it's worth noting the difference between monolithic software systems and new postmodern systems. You may have heard these terms thrown around quite a bit in the terms of Industry 4.0. The systems that are built to suit for specific business or production processes by a single software vendor are known as monolithic systems. And these could be your in-house MES systems that are built just for your company directly. As a result, they're too rigid to evolve easily with changes in the business models. And most importantly, these systems dictate how the business operates. On the contrary, postmodern systems are more user-friendly and simple than their predecessors, meaning they're usually modular and mostly an integration of different types of software suites available in the market, but working seamlessly in a single package. And most importantly, these systems actually let the businesses decide how their business operates and changes with time. Alright, so now we can come back to our software pyramid here. As you can see on the screen, software in manufacturing can be defined in 3 main categories. And in this section, we'll learn about each of this category, their pros and cons when used for plant floor error proofing. The top tier, business planning and logistics software, as the name suggests, it helps manufacturers in streamlining their business operations. The middle tier, which is manufacturing operations and process control, which is also sometimes referred to as manufacturing operations management altogether. Software here helps manufacturers execute, control, and supervise plant floor operations. The last layer is actual plant floor production, which comprises of machines, sensors, tools, etc., but for the longest time ignored the most important part of the shop floor, which is people. And now with Industry 4.0, users and user experience is at the center of this revolution. So, we often get this million-dollar question from different manufacturers. Why can't I have one software that does everything I need, all in one? Well, the truth about that is such softwares are available and exist. Mostly homegrown software that does everything from ERP to MES to shop floor, all in one, for a specific manufacturer or specific company. The problem with such jack-of-all-trade softwares is that they cannot keep up with the rapidly changing manufacturing landscape because such a software is a beast in itself. Such software tends to be more focused on some aspects of the business more than others, and it literally just depends on which teams and which departments had more power on the steering committees of those software development cycles. As a result, manufacturers end up with a system that is not only constrictive, but is prescriptive in a lot of ways. So, for example, a system that is more ERP focused would be really good at ERP functions such as customer service, accounting, HR, etc., but might not be so good at engineering, IT, or plant floor functions. The second type, a machine-focused system, if we look at that, as you can tell, it would be really good at engineering, maintenance, or plant floor processes, but might not be the best at HR, customer relations, or accounting, etc. Now let's get back to our software pyramid again, and starting at the top with ERP, which stands for Enterprise Resource Planning, as some of you may already know. The term ERP was coined by Gartner in 1990s. ERPs are business process management software, which are mainly designed for planning, inventory, accounting, HR, and even sales processes using various software modules. These software modules may or may not be developed by the same ERP provider actually. So let's take a look at this advertised features of an ERP system as an example. Take a moment to look at the number of functionalities provided by the single piece of software. One system capable of providing so many functions. Fantastic, isn't it? Now, I want to draw your attention to these 4 boxes that I marked in red. And if you recall, the MES layer on the pyramid said these functions belong to the MES system. Well, the ERP system is providing those functions here. And if you look at the overarching point here, it's a custom piece of software, and any custom piece of software can blend functionalities of multiple layers into a single software. Also, it's worth noting that ERPs are focused on business planning and some MES functions, but extending an ERP all the way down to the plant floor for error proofing is rare and rather unseen. MESs are either homegrown solutions developed and maintained by in-house expertise, or they're provided by third-party vendors. Traditional MESs could be offered as a module of the ERP system or as a standalone system. Many modern MESs today, they actually extend in both directions to execute the upstream functions of an ERP as well as downstream functions of a plant floor error-proofing software. MES or homegrown solutions are commonly used plant floor error-proofing methods for some very good reasons. It's because MESs or these homegrown solutions actually have some really in-depth data accessibility within the plant structure, and they have an existing integration with most plant floor systems, which actually sometimes may create an illusion that it's a low-cost plant floor error-proofing system, especially for human errors on the plant floor. But MESs were mainly designed and are really good at performing scheduling, plant floor process control, maintenance management, etc. functions. Using MESs for plant floor error proofing would be extremely effective only if all the shop floor errors were machine related, not human related. But we know most errors on the shop floor are human errors. For example, skipping steps, using an incorrect tool, or using an incorrect part. Now, when error proofing the plant floor using an MES that is 2 levels above the plant floor, inherently introduces cost, risk, and delay in the process. This means that plant floor personnel cannot be agile in reacting to changes. Every change that they want to make on the plant floor has to be pushed uphill to the MES layer, and then it rolls back down to the plant floor itself. In sum, this takes plant floor error-proofing control away from the plant floor itself. MES is integrated closely with ERP and other shop floor automation, meaning a need for change of a barcode scan on station 14, for example, has the risk of affecting the entire plant floor production. This makes change request and change management process extremely complex. On top of all of that, MESs that are monolithic in nature are designed with machines in mind and not shop floor workers in mind at all. The next layer on our software pyramid here is the SCADA and PLC. supervisory control and data acquisition. Long acronym, right? And the other one, as you may know, PLC, programmable logic controller. If I had to define both of this in a very simplistic way, SCADA is software and PLC is hardware. That's it. As the name suggests, SCADA oversees plant floor automation, and the PLC actually executes the automation instructions using physical devices. Both of these have been traditionally designed to focus on the physical aspects of production, and they're really good at that, such as line movement, safety, emergency stops, product indexing using sensors, actuators, etc. When we talk about error-proofing with PLC-based systems, these solutions utilizing physical devices were the most original form of plant floor error-proofing in the world of manufacturing. Such solutions are really easy to deploy if the physical devices already exist on the shop floor. Additionally, troubleshooting and maintenance know-how of PLC-based systems is usually available in-house within the controls and engineering teams. Now let's look at the downside of PLC-based solutions. The most important downside of plant floor error-proofing using PLC-based systems is that they're designed for machines and logical processes, and not with plant floor operators in mind. Ladder logic works really well on logical processes. Another downside is that these solutions tend to become too specific. Hence, their adaptation to a change in process, a part, or personnel is sometimes very expensive. And lastly, scaling and upgrading PLC-based solutions requires incremental amounts of physical devices laid out across the plant floor. So now, if we summarize our entire software pyramid discussion here and take a look back at the entire manufacturing software landscape, there are almost no standards or systems that focus exclusively on plant floor error-proofing and the human experience or the user experience. The exact same applies to electric torque tools. Electric tools are relatively new, and hence most MESs or PLCs that control these tools on the plant floor, they use scattered standards for control and data collection, or worse, sometimes no standards. All this time we were talking about the problem side of plant floor error-proofing. But now I'm going to put on my solutions hat. What would be the key features of a plant floor error-proofing system, if you may ask? Ideally, it would be an open platform. Open platform is a keyword here, remember that, meaning any systems can connect to it if needed. Data can flow freely. An open platform with exclusive focus on plant floor error-proofing, especially of human errors, which covers the majority of plant floor errors. It would be flexible for easy change management. It would give the decision power back to the users, meaning if they want to configure specific error-proofing themselves, they can do it. Or if they want to pay for a simple configuration service to a local vendor, they could do that too. It would not corner the users into custom development or black box systems. It would easily scale from a single station to a plant floor to enterprise level, covering global reach. And lastly, it would seamlessly integrate with monolithic ERPs, MESs, and PLCs as well. At a station level, such an error-proofing software will play the role of a virtual PLC, or so-called software PLC, dedicated just for that station, logically controlling every device on that station using a simple, configurable software interface. No programming. It should be all user configurable. This would mean an interactive worker guidance with pictures, videos, etc., RFID barcode scanners to install correct parts only, electric tool control to automatically select the correct tool and correct tightening programs out of many on that station, to accept interrupts from devices such as PLCs, sensors, testers, vision cameras, or other TCP/IP devices. And lastly, a unified data collection system at bolt, part, and worker level to feed into the higher level data analytics systems. Additionally, with increasing complexity and variation in the products, such an error-proofing system would focus on ensuring that using a wrong part or a wrong tool is practically made impossible by the system itself, while providing full sensory feedback to reduce the amount of training needed for new products and new processes on the line. At the plant floor management level, The error-proofing software would bring control of the entire plant floor's processes in the hands of the authorized plant floor personnel. This means changing a simple barcode for a new part or breaking down a complex assembly step into two because the workers on the line are complaining about a lot of errors should be accomplished within a few clicks and immediately deployable in production with complete traceability. And when it comes to data, which is the key pillar of Industry 4.0, this data relevant from all plant floor assembly stations is provided across multiple different software platforms for the plant management to review in real time. And lastly, but not the least, the plant floor system should be able to scale from a single station to a line to plant and global levels without compromising any of the flexibility or the ease of use at the single station level. And to summarize our whole discussion that we just had here, when you look at the essence of it all, names do not really matter, right? MESs, ERPs, IoT, Industry 4.0, and all of the rest that we talked about. It's all about increased agility to improve quality, efficiency, and productivity. Ultimately, information needs to flow to make people's jobs easier, less stressful, and more productive. That's what the fourth industrial revolution is all about.